BESSELI function. BESSELI function returns the modified Bessel function, which is equivalent to the Bessel function evaluated for purely imaginary arguments. The syntax for the Bessel function is BESSELI x comma n. X is the value at which to evaluate the function, and n is the order of the Bessel function. In this video, we will generate the trendline dataset and polynomial of the Bessel function where values of x from 0 to 4. So using Taylor-Maclaurin series sum, Bessel function is equal to the summation of a times x to the power 2k plus n, where a, the coefficient, equals 0.5 to the power 2k plus n divided by k factorial times gamma n plus k plus 1. Our value for k is from 0 to infinity. So 0, 1, 1, 2. We'll try to get to infinity. 10 is good enough. And our value for n will be from, our order will be from 0 to 4. So data validation, we'll use this range, 0 to 4. Save. So we'll generate the data set of the BESSELI function from orders from 0, 1, 2, 3, and 4. Going back to the Taylor-Maclaurin series sum, which is array formula, series sum of the x values raised to the power starting from n, because that's n plus 2k or 2k plus n, and our value for k is from 0 to infinity. So n plus 0, n plus 2, n plus, so our interval will be 2, and the coefficient will be this range. And we'll chart this using scatter chart. Scatter chart. And generate a trend line to the polynomial to the fourth degree. Polynomial to the fourth degree. And show this equation as label. So here we have the trend line equation, or the trend line polynomial, and the trend line in the chart. Next, we'll continue with the coefficient, which is array formula. Let's start with the denominator, which is k factorial times gamma. So factorial k, that's factorial k, times gamma, n plus k plus 1, and plus k plus 1. So that's the denominator part. Now we continue with the numerator, and that will be 0.5 to the power 2k. 2 times k plus n. So at n equals 0, at n equals 1, at n equals at order second order, the third order, and the fourth order. We'll calculate these coefficients of the trend line using LINEST. To do that, we will complete the 1 comma x matrix, starting with the power, so transpose. So it's 4 degrees, so 0 to 4. And enter the 1 comma x matrix, array formula of the x values raised to the power 0 to 4. Now that you have the 1 comma x matrix, we can enter the LINEST. So we go LINEST, we have our data y and our data x. Let's see uh, our trend line if these regression coefficients match to our trend line. B0, that's 4.36 times 10 to the minus 34. Yeah, that's correct. That's very small, small enough to be 0. B1, negative 0.061. B2, 0.118. B3, negative 0.0714. And B4, 0.0169, which is 0.017. So we go back to the 0 order. B1 is 1, B2 is negative 0.176, B, B2 is 0.591, so B1 is negative 0.176, B2 is 0.591, and B3 is negative 0.2079, and B4 is 0.058. The order of 1, so B0 is 0, negative 1.98 times 10 to the minus 33. B1 is 0.32, B2 is 0.355, B3 is negative 0.0161, and B4 is 0.05. The second order, so we have B0 is negative 1.74 times 10 to the minus 33, that's 0. B1 is negative 0.136, B2 is 0.389, and B3 is negative 0.16, and B4 is 0.043. Third order. Our third order is B0 is negative 9.76 times 10 to the minus 34. That's 0. B1, negative 0.104. B2, 0.205. B3, negative 0.107. B4, 0.206, 2086. So let's go back to the example. Let's take the example. This is the example. Bessel I, order 1. So the order of 1. This is the order of 1. So let's order of 1. And this is 1.5. What is the function of 1.5 at 1.5? So we'll copy that, paste this here. That will be 1.5. Enter. So our value is, that's 0.981666, which matches to our result, negative our 0.981666. So this confirms that our trend line and data set is accurate and also complete.